Susan Wickwire, Manager of the U.S. EPA CHP Partnership Program, and welcome you warmly to the webinar today, where we'll have several speakers, two from the Department of Housing and Urban Development, and one from the related company is a private development firm. So you can see here on your screen the agenda for today, where I'll provide a few words of introduction, and then we'll switch to the HUD presentation and then hear from Luke Falk from the related companies. And a lot of you are probably already familiar with our program, but I put this slide up there just to remind folks about who we are and what we do and what kinds of resources and tools we provide to the CHP market. We do have over 470 partners in the program who've put in a number of projects that are achieving great energy efficiency savings and also monetary savings. Please do visit our website on the EPA website to learn more about our tools and resources, where we focus on project development, overcoming regulatory barriers. We provide information on policies and incentives, so there's a lot for people to find there. And then I just had a quick note on some upcoming webinars that we have planned on our work advancing CHP and LEED, and also looking at CHP in the context of critical facilities. We'll be talking a little bit about that in today's webinar. So just for logistics, so we'll be muting all of you during the webinar, but please do feel free to submit questions when they come up. We will be having a Q&A session at the end. We'll also be providing answers for questions, of how things are going, process, that sort of thing, for clarification. And then at the end of the webinar, we hope that you'll take the short survey that you'll see at the end of your on your screen. That'll help us think about other topics that would be of interest to the CHP community. So first, let me introduce our first two speakers from the U.S. Department of Housing and Urban Development. Michael Friedberg is Senior Advisor for Energy Policy in HUD's Office of Sustainable Housing and Communities. Formerly, he was Director of Affordable Housing Technology Research, and he coordinated the agency's efforts to reduce HUD's $5 billion energy bill. And his background is in affordable housing and sustainable community development, where he worked in New York City and also in Chicago. He received his master's in architecture from the University of Illinois at Chicago and a bachelor's in urban studies from Yale University. And so he'll start the presentation and then be joined by Bob Groberg, who worked for HUD for 34 years, and he retired a few years ago, but he's still active working on CHP. And during his long tenure at HUD, he was in various management positions, and he co-chaired the department's energy task force with Michael, and worked very hard to ensure that CHP was included in energy action plans. He helped create new tools and resources to promote CHP in public housing. And he worked with us, Department of Energy and other agencies, to improve energy performance in public housing. And prior to HUD, Bob worked on housing issues at the state and national level, and he has degrees in political science and law and in public administration. So with that, let me turn it over to Michael and Bob to tell us more about what HUD is doing to advance CHP in public housing. Thanks, guys.
Okay, thank you, Susan. Good to be with you. I'm just going to quickly run through a few slides just talking about HUD's interest in this subject and what we're doing more broadly in the sustainability area. Really, we have a sustainable housing strategy and a sustainable community strategy. So next slide. A lot of what HUD does, of course, is by definition housing. We have about 5 million units of affordable housing that we support in one way or another. And I don't have to tell the group here that there are many good reasons why we're interested in energy efficiency and greening this stock. It's obviously good for the environment, good for the health of the residents, and then in addition, it's sound fiscal policy. Next. On that front, I think the figure you used, Susan, was $5 billion that we spend. That must be an old bio where there's about $7 billion that is spent in all of those units. And so just a modest reduction of 5% in that stock could save $350 million a year or $1.75 billion. So significant savings to the government, to the residents, and owners. So next slide. And so just some examples of the kinds of projects that we have been supporting over the past few years, some really terrific cutting-edge projects. Some of them are new construction, such as this one. This is a 98-unit mixed-income building, supportive housing in San Francisco. It opened in 2005. It was one of the first LEED buildings in the Bay Area and actually beats the California Title 24 energy efficiency standards by 20%, funded with a whole range of HUD and state and local resources. Next slide. This is another terrific project. It's actually the first net zero senior public housing project in the United States. We supported this project with Recovery Act monies. 73 units, has PV solar as well as a wind turbine component and ultra-efficient air source heat pumps. So this is really, putting a new face on what most people think of when they think of public and assisted housing. Next slide. And on the renewable side, here's a terrific project that the Denver Housing Authority did, 2.5 megawatts of solar, PV solar, providing power to 387 affordable housing units.
Welcome to GoToWebinar. Webinars made easy.
Just hold on, we have a technical issue right here. Okay, we can go to the next slide. Sorry. Well, actually, just go back if you could. So, but in addition to, obviously, these new projects, there's a huge inventory of existing properties, older, medium, or high-rise properties such as this one. This happened to be one of the first combined heat and power projects in Danbury, which is generating about 2/3 of the electricity and about half of the space heating units and 100% of its domestic hot water needs. So this is one of the early projects and has been replicated in a number of other projects. Next slide. And just looking ahead, a couple of things that are on the front burner at this point. We have just launched the Better Buildings Challenge for the multifamily sector, where we have about 50 multifamily portfolio owners representing more than 1 million units of privately owned assisted housing for the most part, who have committed to a 20% reduction in their portfolio over the next 10 years. And we welcome additional participants and volunteers who are interested in joining that campaign. Next slide. And we also launched as part of the, or are about to launch as part of the President's Climate Action Plan, the 100 megawatt renewable energy target for federally assisted housing, which is essentially to take the Denver experience and some of the work that's being done through the MASH program in California and replicate that in many other parts of the country. So next slide. On the sustainable community side, we are actively partnering with EPA as well as DOE and the Department of Transportation to support communities to focus on location-efficient and transit-oriented development, as well as more sustainable growth strategies around the country. Next slide. And we awarded over $200 million in grants to all of these communities throughout the country to develop sustainable community plans that address energy efficiency, but also transportation, housing, and water and waste management, and a variety of other sustainable scenarios. So that's been very exciting. So looking ahead, next slide. So looking at CHP, this is very much an extension of what we're doing in these areas. We have been working particularly in New York and New Jersey with the state and cities in that part of the country in post-Hurricane Sandy recovery planning and implementation. And we produced this guide, which we really wanted to bring to your attention today as a resource for folks who may be interested in looking at CHP as part of a disaster recovery and climate resilience strategy. The report was really an extension of and a response to the couple of recommendations in the Hurricane Sandy rebuilding strategy that HUD chaired, which described how CHP can play a successful role in, and in fact did play a successful role in keeping a number of college campuses, multifamily housing, critical medical facilities, sewage treatment plants, and other facilities running during the storm and its aftermath. So we are very interested in seeing how CHP can be expanded to support facilities' continued operations in these kinds of disaster situations. The rebuilding strategy report offered 2 recommendations to bolster CHP, which included encouraging federal, state, and cooperation to improve electric grid policies and standards, as well as ensuring that Sandy recovery energy investments in critical infrastructure are resilient. Next slide. So the key components of the guide were it makes the case for CHP as a reliability and a resiliency strategy. It does talk about some of the requirements and costs associated with a CHP system that can run independently of the grid. We do discuss at a relatively high level how developers and program implementers can decide whether CHP is a good fit, as well as comparing it to other options for supplying power, including backup generators. And then we do have a very general section about some financing options. So we encourage you to take a look at this at the guide. Next slide. The bottom line is that we do see CHP systems as allowing facilities potentially to remain functional in a disaster area. We believe that CHP systems can effectively contribute to state and local planning efforts. Fortunately, we have some good partners in the Northeast in the Sandy recovery zones. As I'm sure many of you know, New York City published a plan in June 2013 to improve building and other codes that would enable increased use of CHP for emergency power. New Jersey is addressing this through their energy master plan. And then we've also seen some good efforts in Texas and Louisiana post-Katrina adopting legislation that critical government buildings must evaluate installing CHP. So the bottom line is that I think there's some positive developments And at the end of the day, though, we do want to obviously highlight the fact that in order for CHP systems to continue to operate when the grid goes down, these systems have to be specially configured to operate in island mode. So I've probably taken too much time, Bob, already, but if you can take over, we'll go to the next slide.
Well, quickly speaking about going into island mode, the guide identifies the components necessary. Michael mentioned black start capability. You have to have a generator capable of operating independently of the grid. It has to have ample capacity to carry the building's key loads, and it has to be set up in a way so that it can interconnect very quickly when the grid goes down. Next. The question of whether CHP is a good fit for your building is something that EPA began identifying some years back, and it considers the costs. The payback period varies depending, from HUD's point of view, public housing can finance with energy performance contracting and go 20 years. A privately owned assisted building might require under 10, and I've heard even low numbers. But with the demonstration of the public benefit of remaining on having electricity in a disaster, I think has identified for us a way of quantifying the value of this additional cost. Next. When I was working on this to start with, I tapped NYSERDA's early demonstration in New York, and what you will find on footnote 46 in the guide is the HUD page that has several publications, guides that I developed in cooperation with NYSERDA. The first one is aimed at multifamily building owners and managers. What is CHP from their point of view, not necessarily from an engineering point of view. The second deals with a feasibility calculation system that Oak Ridge Lab developed in response to HUD's request, and it enables a building owner to enter some basic data to determine whether or not it would pay back. Something as simple as monthly utility costs and current utility rates, gas and electricity, and the difference between them. And a building owner can get a fair estimate of payback. That system was developed before the calculations for islanding were identified. And one of the key opportunities here following Sandy is to identify the costs for islanding each of the properties that is identified in the back, in the appendix of the guide. There's a checklist in this guide number, HUD guide number 2, that building owners should look at before they even try to do all the calculations for their monthly costs. Next. There's been a lot of discussion about how expensive it is and whether it would pay to have a backup generator. And one of the problems with backup generators is that they require constant attention during the year to make sure that when they are needed, they will work. And so the experience with them is uneven. Next. There are 3 examples here of success, and they all survived and operated. The Greenwich Hospital operated for 7 days after the grid went down, and Salem Community College for about 48 hours. The Brevoort is the only one of the 6 multifamily installations identified in the guide, which includes Co-op City. Co-op City grid did not go down. It has its own special grid and was able to continue generating. But the Brevoort in Lower Manhattan is an example and has some rather dramatic experience where the equipment senses a weakening in the grid and has to decide at what point to go black start. And they finally did, and it took about 15 minutes to convert over and repower the building. There are about 700 residents in the building, and they were able to serve as a community resource and bring in neighbors as well as family who needed electricity. In New York City, if you don't have electricity in an apartment building, you don't have water. So people had to climb down the stairs, get some water, go upstairs just to flush their toilets, which made a big impression on I think, on the whole market. What is the value of maintaining your electricity capacity? Next is the closing slide, and I should say that we will be looking for answers to the questions of what it took to island each of the properties.
Right. So thank you, Bob. That Brevoort example, is a sort of a great case study in how one building was able to be a model for apartment buildings, continued operation, and clearly one of our interests here at HUD is to see more residential applications of CHP. And I know that's been a big thing of yours over the years. So with that, Susan, over to you or over to Luke.
Sure. Thanks so much, guys. That was great to get the perspective from HUD and learn about what you're doing on multiple fronts in terms of promoting sustainability in public housing, and then, of course, to see how CHP fits into that. And so we're going to be turning from the public sector to the private sector. And so Luke Falk is with us. He's the sustainability manager at the Related Companies, where under the direction of the VP for Sustainability, he supports the implementation of Related's corporate sustainability strategy. And this includes focusing on enhancing the energy performance of new and existing buildings, benchmarking, monitoring, and incorporating new and innovative technologies. And prior to joining Related, Luke was a project manager for NYSERDA, the New York State Energy Research and Development Authority, of course, and in that capacity, he managed a suite of statewide energy efficiency and green building programs targeting the multifamily housing market. Luke has a bachelor's degree from the Colorado College and a Master of Urban Planning from NYU's Robert F. Wagner Graduate School of Public Service. So, Luke, looking forward to your presentation. Thanks.
Great. Can you see my screen?
Yes.
Okay. So thanks for having me. It's a pleasure to be here. I think I'll just start by saying the Brevoort project was one that I was responsible for when I was at NYSERDA, so I was happy to see how it played out over the course of Sandy and beyond. Pretty interesting and cool. So, yeah, I'm going to talk mainly about the multifamily application for combined heat and power, and I made a broad-based.
Welcome to GoToWebinar. Webinars made easy.
And loads and whatnot, but I wanted to provide, a fundamental premise upon which more targeted discussion could follow. This is an image of a project with a 75 kW reciprocating engine that is just about to get TCO in the next couple of months on 30th and 10th in New York City. The Related Companies is one of the largest privately held real estate firms in the country, if not the world. We have a large portfolio of assets that we own and manage, most of which are multifamily, some of which are commercial and mixed use. We have a large retail division, and we do development all over the world. So not only are we owners and managers of a large portfolio, but we have a tremendous amount of development underway, primarily in New York City, but also a very robust presence in California, Florida, Chicago, and a growing presence in Boston, Washington, D.C., and abroad. To date, we have I'll just keep this. Sorry that I kicked that off there. So, excuse me. We made a corporate commitment to do all of our new development LEED Silver or better a couple of years back, and this is a list of properties that meet that requirement or exceed it, and you can see their energy performance as measured against energy code, different versions of ASHRAE depending on the year. I'll say that the ones in red are different assets within the same building. Currently, we're working on dozens of projects across the world, which include a diverse mix of asset classes in a diverse mix of locations. In our pipeline right now, we're developing over 7,400 apartments in many, many buildings. All told, it's over 21 million square feet of space that's in active development right now, which represents over $10 billion worth of investment. Part of that is the largest development project in the history of the country, which is called the Hudson Yards, and comprises a roughly 26-acre brownfield redevelopment site on the west side of Manhattan, in between 10th Avenue and 12th Avenue, in between 30th Street and roughly 33rd Street. The first phase of that project is called the Eastern Rail Yards and is comprised of 5 very large-scale buildings, which will have cogen and will also have a mixed-use component. Like I said, everything that we do is LEED Silver or better. Most of the projects that we're doing now are probably going to wind up being LEED Gold. One of the benefits to us for cogen, so what I want, now that I've introduced who we are and what we do, I wanted to talk about why we like cogen. In New York, we really like cogen primarily because of the economics of the installations. I'm a big environmental advocate. I worked at NYSERDA for 5.5 years. I teach a class about energy efficiency. I'm a big fan and a true believer in energy efficiency. But beyond the environmental benefit of efficiency, the economics of these transactions are very compelling on their own. And it helps that when you model the building against energy code for code compliance generally or for performance through the LEED rating system, the cogen gives you a big performance boost relative to a building without cogen because of the source energy benefits of the efficiency boost that you get. But more and more, one of the attractive elements of the cogen plants that we're doing have to do with the black start capacity that they afford and their ability to supplement code-required emergency generation systems in the new assets that we're developing. I guess we'll take questions at the end. Normally I get interrupted by a large group of people, so I'm not used to just being able to speak. But This is an image of a building that we're doing in Tribeca, where we also have a 75 kW recip. And the reason why I flashed the energy performance of our past projects at the beginning of the PowerPoint was just to give you a brief sense of the level of enhancement relative to code we were seeing in older versions of the ASHRAE standard. And if you see peppered throughout the presentation, I have images, all of which are buildings measured against the newer 2007 version of the code, which is said to be more stringent than the old versions of the code. So our energy performance seems like it's enhanced greatly by not only the cogen, but all of the other energy measures that we bring to bear on the projects. So what I'm going to talk about is a brief overview so that we're all on the same page about the kind of systems that I'm talking about. I'm going to run through the economics as I see them for a typical multifamily application in New York City. And then, at the end, if you have questions about what it's like with a more commercially oriented facility or not in the city, we can talk about that too. And then some miscellaneous design considerations, permitting, and ways to figure out what incentives are available. This image is of a building that we're going to be doing on East 92nd Street, which is going to have 200 kW of inverter-based recip engines that will have black start capacity. So in the event of a grid disruption, we'll be able to operate in concert with a backup generator. So the reason why cogen is a great application in New York, not only because of the economics, but from a public policy perspective, is because Zone J, which is New York City and Westchester, as the New York Independent System Operator calls it, is a load pocket. So we are capacity constrained. The City of New York also has a law on the books that says 80% of the system peak capacity on any given year needs to be generated within the 5 boroughs in order to address that load pocket issue. So reducing system peak through base loaded measures or curtailment is a huge issue in New York City. So cogen does that by removing the base of the peak load profile. Why does cogen present compelling economics? Well, if you look at the energy flow chart of the way that energy moves through the U.S. economy, you can see that if you look here, this is the electric sector, right? And you've got primary fuel input going into the grid, and only a third of it comes out of the system as usable energy, whereas 2/3 is rejected as waste heat. Whereas in a cogen system, you get, and I stole this slide from our hosts today from their website, you get fuel going in, and you have an engine or a turbine, and there's a generator that makes electricity, which is used in the building. So that is roughly equivalent to the efficiency of the generation side of the grid. I mean, a little less so, but roughly equivalent. But then you've got a series of heat exchangers that take the waste heat and put that heat to some productive use. And these efficiencies are sort of ballpark generalizations, right? There are certain systems that are better, there are certain systems that are worse, but I think that we can all agree that that's about where you're going to land. I want to be very clear that my remarks today are focused mainly on the type of systems that you'd find in multifamily housing. And in my experience, that means that there are a couple of reciprocating engine vendors out there that have a manufacturing component to them, and a microturbine product that dominate most of the market. Now, you can go and find other products out there, but in my experience, there are a few actors that dominate most of the activity in the market, and they are manufacturers who provide a product and maintenance, and they're sort of like a one-stop for their specific cogen solution. So let's talk about the design. So the first thing that is most important from an economics perspective and making the system work is that you need to have sufficient electric load in the building to justify having a piece of equipment that is ideally constantly producing a flow of electrons that need to be used productively somewhere. So the size constraint in most multifamily is that there's a direct metering configuration with the utility where there's one big meter for the house account, which all of the load for the base building lands, including elevators, corridor lighting, pumps and motors, maybe a cooling tower depending on the heating and cooling system configuration, all the fans for ventilation, and all the miscellaneous plug load for the common area. All of the apartments typically, not always, but typically have a direct metered connection to the utilities. So their refrigerator, lights, and plug load are all running off their own little utility meter. If that's the case, then the opportunity to deploy cogen in that building is going to be much more constrained relative to a scenario where all of the electric load in the entire building is falling on a single meter. And so this is a graph of the common area electric load that I measured on the house account of a building that has about 450 apartments. And on the vertical axis, you can see that, well, it's the average kW during a 5-minute interval. And so what I like to do with our cogen systems is to base load them electrically, because if they're oversized, then you either need to ramp them down and there's a potential for their part load efficiency to not be as robust as their full load efficiency, or you just have excess power. Mainly you won't. You'll just ramp them down. If you ramp them down, maybe there's an efficiency issue, but certainly your payback is going to be extended in terms of your time horizon. So, you know, if I were counting on the full load output of a machine to get a 5-year payback, and I'm only running it at 75% load, that 5-year payback is going to increase by 25%. So it's super important that the systems have a place for their electrons to go. Now, I was wondering what was causing all the spiking in this chart. We think that it's the elevator, but it could be, you know, there are a lot of things that could cause a profile to look like that, whether it's a domestic water booster pump that is really large and takes a lot of capacity banging on and off. So you really have to have a pretty finely grained understanding of what your load profile looks like before you want to start sizing a system. And in new construction, you know, you need to just really pay attention to what you think you're going to be at, and then I like to be very conservative relative to that analysis because it's great if a cogen project outperforms your projection, and it's always a real unfortunate circumstance when they fall short of your expectation. The other element to doing a proper sizing is making sure that there is use for the heat output, because if you're, you know, in New York, maybe it's something like you can generate a kWh for 13 cents, or maybe it's about 15 cents but you can buy from the grid for 18 cents, so you're making a spread on all of the kWhs that you generate. If you relied on that spread, you would have a very, very long payback. It's only the ability to capture the waste heat and use it productively that gives the cogen system its payback. And I think that when you talk to the design engineering community, in my experience, there is an impulse to oversize the domestic water system. So when you look at the nameplate of your domestic water system, it might lead you to the understanding that you have more of a domestic water load than you actually do. And so it's important to do the BTU metering or some pre-retrofit M&V to ensure that you actually do have the thermal load. Now, in buildings with absorbers where you're doing cooling off of some sort of hot water, and in the winter you have a condenser water loop or a hydronic heating loop, then you're golden, and you know that you're going to have some way to use that waste heat. But most multifamily that I encounter doesn't have absorber-based air conditioning. So my preferred strategy is to size the cogen plant so that it is base loaded for the domestic hot water production as well. Now, you can oversize it relative to that if you're comfortable not running the system 24/7 in the summer. But again, it just has to do with your cost-benefit analysis about how intermittently you feel comfortable running that system. So this is a load profile of a gym, like a fitness center that's housed in one of our buildings, because I was trying to figure out how to size the system for a building that's going to have 250 apartments and maybe an educational facility and then a large fitness gym center. And I wanted to get my mind around what is the hot water profile of a typical gym. And so you can see that there are peaks and valleys. The way that you deal with that is by having some sort of thermal storage tank where you can store the thermal output in hot water and warehouse it until the system starts to peak and you drain down the BTUs out of your thermal storage tank to serve the peak of the load. And then you recharge it in these valleys. And the design challenge is to know how peaky those peaks are going to be and how low those valleys are going to be and what the optimal size of such a thermal storage tank would be. In my experience, it turns out that it's usually about 3,000 gallons. So the approximate economics of cogen in New York City, now there's a couple of caveats here. I tried to develop what I would think of as a relatively general rule of thumb type analysis for the presentation. These installed costs can go up or down depending on your level of sophistication. I didn't use our actual installed costs because I don't know that it would necessarily be representative for the entire field. Anyway, this is the way I look at it. You look at your kWh output, you look at how much usable thermal output you get, how much of that thermal output you're able to recover and use, how much you think you're going to dump over the course of a year, and what your gas input is relative to this energy output. Then you factor in your maintenance cost. These numbers, the thermal utilization is driven by how much is being dumped, so that's correlated to these like percentages used. And then you have your installed cost, and you can, given the cost of electricity that you're offsetting and given the cost of gas that you're offsetting by not having to use your boiler, you can figure out what your annual savings are net of maintenance, and you can figure out the payback from there. I think this is fairly representative. If we have questions about specific elements of this at the end of the presentation, we can flip back to it. I guess one of the questions would be, if the typical recip has a better payback than a typical microturbine, then why would you use a microturbine? And I think that I'll speak to that later on in the presentation. So one thing that I wanted to spend a lot of time on was this question of how does cogen play into a resilience strategy. It's been a very interesting experience having been working for a developer through the experience of Superstorm Sandy. We had a couple of projects in design and one that was already going into the ground when that happened. And we've done a lot to future-proof our buildings against a flood scenario. I don't want to get into everything that we're doing, but cogen and the ability to have on-site power is certainly part of the discussion. Now, in New York City, I can speak to how it is here. It might not be the same sort of scenario all across the country in that New York has two different codes that apply to buildings seeking to install backup generators. One is that if your building is greater than 125 feet tall, you're required to have a backup generator. And it needs to serve three primary loads. You need to pick up an elevator that serves every floor of the building. You need to provide sufficient lighting for emergency egress, which I believe is defined as 2-foot candles on the floor and all common spaces. And then you need to pick up a fire alarm so that your building can be fireproof. If and the last thing I'll say about the requirement there is that you can use natural gas in residential buildings. And I believe that they either are changing or have already changed the code that prohibited the use of a gas-fired generator for backup in commercial, which for the longest time was the case. You could only use oil. Now, if you have an existing building and you want to put in generation capacity so that you can have some functional occupancy and facilitate in-place habitation during a disaster, there's a voluntary code that you need to follow, and it requires you to pick up all of those three systems that I just mentioned. The issue there is that if your plan is to use cogen as a means to facilitate in-place habitation instead of a backup generator, then there's probably going to be some tension in between the optimal size to derive the best economics for the installation and your ability to provide enough power to have a meaningful impact on resident comfort and functionality in the event of a blackout. So like if you need to pick up a 65 kW elevator and 50 kW worth of lighting, all of us, and then a fire alarm, let's call it 25 kW, if that's probably high for what that is, but let's say it's 120 kW of load, all of a sudden your plan to maybe help people charge their cell phones or power a Wi-Fi system or power booster pumps to allow them to flush their toilet or get hot water is undermined by the requirement that you provide the code required building systems to be picked up on your backup generator. Now, that's another code that was being looked at by this resilience task force in New York, and there was talk that it was going to be relaxed, and I don't know if it ever did get that or not. So I'll move off of that point, but it's something to pay attention to. The other thing that I wanted to call to people's attention is that in New York, the backup generators need to be compliant with a specification called NFPA 110, which means that the generator can come on within 10 seconds of a blackout. And to my knowledge, there's only one small cogen system on the market that has that certification, which is, not only NFPA 110, but a broader certification called UL 2200, and that's the Inverde 100 model from Tecogen. Oh, no, that's wrong. That is the microturbine from Capstone. And so before, when I was talking about why would you use microturbine over a recip, the reason is the microturbine carries a certification that allows you to have black start, to have that functionality, to comply with code, if you're able to size it in such a way where you could supplement your emergency, you could completely eliminate your emergency generator altogether. The last thing I'll say about it is that all of the systems that I've used that have black start and can run when the grid goes down are inverter based. So just keep that in mind. One reason that you'd want to use a microturbine instead of a recip as well is the thermal rejection requirements. So the recips tend to have a slightly more fussy design where you need dump radiators and a glycol loop running from the system, and the radiators can be loud and they need outdoor space. So if you're space constrained and you don't have that opportunity, the microturbines are air-cooled, and so they don't need a dump radiator. However, if you use them, you need to supply and exhaust a large volume of air to the space containing the microturbine. So neither of them are without requirement, but one requirement may jive with your project requirements better than the other. One of the things I want to mention is that we spent a long time trying to figure out if the cogen and a boiler plant could share a flue, and what if it was a condensing boiler, because condensing boilers have acidic flue gases, and you need a certain alloy, but maybe the cogen exhaust was of a high temperature and wouldn't work with the alloy. It turns out that we were able to solve that. You can do it. In New York City, you need a letter from the cogen manufacturer and the boiler manufacturer that they can share a flue. They just need to be configured in such a way that neither of the pieces of equipment is going to present back pressure issues that make the units fail. So you need to put them in the right order as you go out the building. In New York City, there's a bunch of documentation about how to successfully navigate the regulatory superstructure that wants to regulate cogen. The fire department gets involved, Department of Buildings gets involved, DEP from an air quality perspective gets involved somewhat sometimes. And then there's the interconnection with the utility, which is something that you're going to have to consider. I didn't even talk about tariff implications or rate impacts, primarily because the systems that I'm talking about, at least in New York, meet an efficiency requirement which exempts you from having to go on a standby rate. But if you're using an inefficient cogen, or you're subject to the standby rate regardless of the equipment that you're choosing, that is a super important thing to pay attention to. And finally, I'm going to say that if you want to find incentives to help pay for this stuff, EPA has a really great database that they update on a biweekly basis, where you can search for all of the incentive programs and grants and loans and other germane documentation to help guide your effort.
Thanks, Luke. Really appreciate the presentation and the plug for our resources. That was unsolicited, in case anyone's wondering. But anyway, we'll have a short time to do a Q&A here, and I think as my slide originally said, we'll be sure to address any questions that we don't get to in the active webinar. We'll do that by writing after the session's over. And I think we can go a little bit over if people are indulgent, but we'll just try to get some of these key questions that have come in during the course of the webinar. And one of them, I would say, sort of touches upon elements of both presentations, so I would invite Michael and Bob and Luke to chime in. But there's a question about the duration that a property can be islanded with CHP and what those implications might be for emergency response. And the sort of a related question is whether if CHP is being fueled by gas, is that something that can be considered resilient? So Luke, you start, and then if if HUD wants to chime in, that'd be great.
So the question is, if it has to be supplied by gas, is that really resilient?
It is, and then how long do you think your CHP system could go, assuming that you have fuel, I suppose?
Well, I mean, so if it's a gas fire, so the gas system in New York during Sandy, as far as I know, and what I've been told, is that service wasn't interrupted. So, yeah, it's completely true that if your on-site power system is reliant on an outside power supply, then it's subject to disruption. It turns out that during Sandy, it wasn't disrupted. So if you had a gas-fired generator or cogen, they were running without problem. Now, there's electrical infrastructure in the building that is required to make all these systems work, and a lot of that, depending on the location of the building, was undermined by flooding. But
Right.
to the extent that you have gas flowing into the building, your cogen can run. And then when it stops, it's over.
Do you want anything to add to that, Michael or Bob?
I think we're good on that.
Okay, great.
Yeah, I mean, obviously the big challenge is the grid going down, and there obviously is a danger of losing gas power as well. But fortunately, that was not the case up in the Sandy situation.
Okay, we have another question I think can apply to both presentations that we heard today because of the interest in the LEED standard by the U.S. Green Building Council. There's a question about what advantages does an owner have by getting his building certified with the LEED standard, and also if I think, Luke, you made a point to talk about how CHP could be involved in that, but why don't we talk just a moment about the role of LEED and how that helps a building owner in any case.
My perspective on it is that, it's a way to differentiate your building in the marketplace, depending on which market your asset is located within. And in certain market segments, it's a necessary predicate to claiming that you're the dominant asset in any given asset class. So like Class A office building in New York City, you pretty much need to get LEED certified if you want to make the case that you are among the best in that submarket. So it depends where your building's located. But yeah, I mean, it's a way to differentiate yourself and say my building is greener, more sustainable, more energy efficient.
Anything from HUD on this one?
Well, I guess the question was, and I'd be interested in Luke's response having done these LEED buildings, is can you get to LEED sober, I assume you can, without a CHP system, or how much can this contribute to you getting a LEED sober rating?
Yeah, I mean, you can get to LEED silver very easily without a cogen. And the cogen helps you tremendously on the energy and atmosphere credit 1 section of the rating system. So I think, in a typical building where you could see 100% utilization, it's like somewhere on the order of 12% energy cost savings building-wide. So that translates to, whatever, 2, 3 LEED points, 3 or 4 LEED points. I'm not even sure exactly. But it gives you a very robust benefit with your LEED scorecard.
There is a trade-off between the level of efficiency and the amount of thermal that you need, and you reach a point where you may not need enough thermal for the building to make the numbers work for cogen.
Totally.
Right, right. And just to say, as I said at the outset of the webinar, in terms of the LEED issue, that's something that we're looking into here at the partnership and talking to a lot of stakeholders out there, and we'll hope to bring the results of our research to everyone's attention through a future webinar. We have time for just a couple more questions, and again, if we don't get to it, we'll be sure to respond to you in writing, and then those answers will be made available to everyone. There were a couple questions about just black start capabilities and other systems like Yanmar 5 kW and the 10 kilowatt micro cogen units that are also can be used and can be certified. But there was a question about does it was mentioned that the capstone system can eliminate the need for a diesel or oil backup generator, and there was a question about does this include the fire pumps, and that's something that would probably be very important. So Luke, do you have an answer to that one?
Yeah, well, so in my experience with the fire pump, I believe that you can choose to wire that in one of two ways. You can wire the fire pump to the grid side of your electric system, or you can pick it up in-house, because the idea is that if something catastrophic is happening to the building, you can run your fire pump from the grid rather than from your emergency generator. And so the fire pump is a really large load. So if you're trying to use cogen as backup power, that becomes a very expensive item to pick up because every kW of cogen capacity, is between $200 and $4,500, right? So either the answer seems to be wire that pump to the grid directly, or put it on an emergency generator where your dollars per kW of capacity is vastly less expensive than a cogen system.
Well, that's very helpful, Luke, and we actually got a question about calculating the avoided cost that can be added to the payback for putting in some of this Black Start capability and handling some of these emergency loads. And I think you gave a flavor for the range of costs that could be involved, and this is something that we've looked at here at the partnership and have some information on, and there's some also information in the guide that Michael talked about and Bob talked about in the first presentation. So actually, unfortunately, we've reached the end of our time here, a little after 3, and we really do appreciate the participation of our speakers, Michael, Bob, and Luke, and all of your good questions and your attention here today. And we look forward for people to join a future webinar from the CHP partnership. So with that, we'll close, and please do fill out the survey that you might see on your screen, which will hopefully come up soon. Do you have anything to add, Jake?
Yeah, I just want to let our attendees know that a recording of this webinar will be available on the Combined Heat and Power Partnership website within about 1 week. And as Susan mentioned, also please fill out the survey after the webinar. That's really important for us. And finally, any questions that were not answered during the question and answer will be responded to by email after the webinar.